On today's episode, launch escape systems save lives in spaceflight. Today's episode is brought to you by Engineering.com, a globally trusted source for engineering content. Check out this and many other exclusive videos for the engineering professional found only on Engineering.com TV today. For the 60 years of human crewed spaceflight, a single factor has remained constant throughout. It's dangerous. 19 people have died in spaceflight over that time, 10 during the re-entry phase and 9 during boost. Launch is generally understood to be the most dangerous part of crewed spaceflight. A fully fueled spacecraft and booster is essentially a gigantic explosive charge, and the combination of vibration, air loads, G-forces, and the need for precise trajectory control put a premium on structures, testing, and simulation. Astronauts and cosmonauts have been protected during the boost phase in two ways. By using a launch escape rocket motor to lift the crew capsule away from the exploding booster, and in Gemini and developmental Space Shuttle flights with crew ejection seats. The capability for crew escape has always been there, but in US missions it's not been used in flight since Mercury Atlas III in April of 1961, until this year. Blue Origin's September 12th New Shepard 23 mission suffered a booster explosion during climb, with the capsule separating and parachuting to safety. Like the NASA flight 60 years ago, sensors detected the breakup of the booster and ignited rockets to propel the crew capsule away from the fireball. The original NASA system, similar to the one used today in the Space Launch System with Orion capsule, used a tractor rocket assembly to pull the spacecraft free in an emergency. Launch escape systems used by Blue Origin and SpaceX use pusher engines with no tower. While both Mercury and New Shepard capsules were not crewed, launch escape systems have saved lives from an exploding booster once, on September 26, 1983. The Soyuz T-10-1 mission, carrying 2 cosmonauts intended to link with the Salyut 7 space station, suffered a booster fire on the launch pad. Flight controllers activated the launch escape system and 2 cosmonauts endured over 14 Gs of acceleration for 5 seconds, landing bruised but safely away from the explosion. So what's the better way to protect crews? Is it ejection seats? Push them off the booster or pull them away? Ejection seats are heavy and require the installation of pyrotechnics inside the crew compartment, a safety issue. Tractor-type escape towers are heavy, but can be jettisoned as soon as a ballistic freefall escape trajectory is possible, lightening the spacecraft for orbit insertion. Pusher-type rockets are lighter, but the weight must be carried to orbit. Pusher and tractor rockets are in use today and both are crew-rated. Ejection seats appear to have fallen out of favor, at least until crewed orbital spaceplanes are developed again, where they can offer protection during the approach and landing phases of flight as well as launch. But if you're planning to buy a ride on a SpaceX or Blue Origin capsule soon, the good news is 2 types of escape systems are well tested and they work. Well, that's it for today's episode of This Week in Engineering, brought to you by Engineering.com. For our deeper engineering series, visit Engineering.com TV for exclusive shows like Manufacturing the Future and Designing the Future, not found on our YouTube channel. The links are in the description below. Thanks for watching.